Hi and welcome. In this video, we will introduce another family of functions, namely the family of rational functions. The parent function for the family of rational functions is y is equal to f of x is equal to 1 over x. Because of the ratio, the domain is all real numbers without zero because division by zero is not defined. Let's start our journey of rational functions by sketching the graph of y is equal to f of x equals to 1 over x due to the fact that we cannot use 0. For that, we use some values from the domain, for example, -2 for which y is minus 0.5, -1 for which y is -1, and so on and so forth. And then finding all these pairs in two-dimensional space, we get that the graph of this rational function y is equal to 1 over x has two parts, the lower part and the upper part. The sign of this function is negative when x is negative, and the sign of the function is positive when x is positive. As we can see clearly in the graph, for negative x, the graph is below x-axis, and for positive x, the graph is above x-axis, and the two parts are being separated by the y-axis, in which x is equal to 0, for which the function is not defined. The function is decreasing all the time. As we move, for example, from minus infinity up to 0, the function is going down here. Likewise, as we start from 0 and go to plus infinity, again, the function is going down. We can apply all types of transformations to the parent function. For example, shift the parent function 3 units to the right, that is f of x minus 3, which becomes 1 over x minus 3. Let's name it m of x, and then shift m of x 6 units upwards. That is y is equal to m of x plus 6, which is 6 plus 1 over x minus 3. Note that the effect of multiplication of a rational function with a constant number is the opposite of what we have seen, for example, for polynomial functions. If a is positive multiplied with a rational function, this results in expansion. And if a is less than 1, of course bigger than 0, and if we multiply such a number with a rational function, the result is shrinking. In other words, if you consider these three functions, that is the blue one is y is equal to f of x is equal to 1 over x, then the orange one is 2 times 1 over x is the expanded version, and the green one, which is h of x, is 0.5 times 1 over x, which is the shrunk version of the function y is equal to f of x. The general form of a rational function is y is equal to f of x is equal to k plus d over ax plus b, where a is not obviously 0. Then let's find all transformations present in this general form. For that, we take a as a common factor first here. Inside we have x plus b over a. Then this d over a is the division of these two numbers. As a result, we have k units upwards or downwards shift depending on whether k is positive or negative. B over A units left or right shift depending on whether B over A is negative or positive down here. And D over A units expansion or shrinking depending on whether D over A is bigger than 1 or less than 1 bigger than 0. For example, consider y is equal to 4 plus 12 over 3x minus 6 and write all transformations. We start off with taking 3 as a common factor outside. As a result, we get x minus 2 inside here. We know that 4 is 4 here, 12 by 3 is 4 times 1 over x minus 2. As a result, we have upward shifts of 4 units because of this 4, right shift of 2 units because of this minus 2 down here, and expansion by 3 units because of this plus 4 up here. Consider g of x, which is 10 minus 15 over 30x minus 15. Again, we start with taking 30 as a common factor. We get x minus 0.5. 15 divided by 30 is 0.5. Then 10, 15 divided by 30 is 0.5 again. Down here we get x minus 0.5 alone. And we take minus because of this shrinking factor is negative. We take minus outside. Minus plus divided by minus is minus. Minus divided by minus is plus 1 over 2. This remains the same, 1 over x minus 0.5. As a result, we have downwards shift of 10 units, 0.5 units shift to the right, and 0.5 units shrinking, and of course, because of this minus sign out here, x reflection. h of x minus 2 or minus 4x minus 6. We again start with taking 4 as a common factor here, 4 minus 6 minus 3. And then 2 over 4 is 1 over 2 times 1 over minus x minus 3. Taking minus 1 outside as a common factor, we get 2 plus 1 over 2 times 1 over minus x minus 3. As a result, we have 2 units shift upwards, 3 units shift right, shrink by 1 over 2 units, and of course, O reflection. Why O reflection? Because we have a y reflection here and an x reflection here. Putting them together, the y reflection of the x reflection is the O reflection. Next, consider the function y is equal to h of x minus 2 plus 1 over x minus 3. Sketch its graph and specify its domain and range. We know that the parent function is being shifted 2 units downwards and 3 units to the right. Let's start with the parent function, which is this one. This is y is equal to 1 over x, which is the parent function. Then let's shift it 3 units to the right. That means everything being shifted 3 units to the right. This is 1 over x minus 3. Now what we do is we shift this y is equal to 1 over x minus 3 2 units downwards. That is 2 units downwards. As a result, we get this function here, which is y is equal to 1 over x minus 3 minus 2. Clearly, we can see in the black function here, the last function, that the domain of this function, it's all real numbers without 3, because 3 is where the two parts, the lower part and the upper part of the function, are being separated. And of course, the range is also all real numbers except minus 2, because you see minus 2 is something which is not assumed by the function. Another example, consider y is equal to p of x equals to 3 minus 16 over 2x minus 8. In order to identify all transformations here, we take 2 as a common factor down here, that is x minus 4. Then divide 16 by 2 times 1 over x minus 4. 16 by 2 is 8 times 1 over x minus 4. And then we take this minus outside. As a result, we get minus 3 plus 8 times 1 over x minus 4. Hence, we have downwards shift because of this minus 3 units, right shift of 4 units, expansion by 8 units, and of course, we have, because of this minus sign, x reflection. Exercise for you: find all transformation, sketch the graph, and specify the domain and range of the following function: y is equal to t of x, y is equal to m of x, and y is equal to n of x. Thanks for watching and good learning.